Today we're launching a new format, or rather a new video series, called Regit. Regit is a concept I've been wanting to explore, especially with you guys. The idea came from a follower who asked if I could use their assets in one of my videos. And after thinking about it, I said yes, absolutely, this is a great idea. And the concept is simple. Showcase your creation, whether characters, creatures, or props, by creating control rig for them, while also showing you the best way to handle this situation. And by participating, you will see your creation turn into a concrete control rig, share your work with the community through the videos, and of course, receive the final control rig for your assets. What do you think about the concept, guys? Let me know in the comments. It would be amazing to work together on real examples, because this is the spirit I want for this series. Today we'll practice with our friend, a minion, which I quickly recreated in Blender and Unreal. How do you set up a control rig for your character's eyes? Let's go. So this is the initial setup. I've put together a simple control rig logic for the character, and here the main focus is on the eyes. Normally we want an EyeBoard type control, something that works like an IM constraint, where both eyes can be constrained to a target, but with the option to still manipulate each eye individually. On top of that, we also want the ability to drive some of the material's attributes of the eyes, not just their movements. So how do we achieve all of this in Unreal? You'll see, it's actually quite straightforward. Next, let's set up the eye controls. We'll start with the eyelids, which are simple FK controls. I've created an eye master joint to make it easier to drive and scale both the eyes and the lids together during animation. From here, let's create a control shape, say a box, and offset it with Ctrl plus num dot. Then we'll mirror that process on the other side. For the lids, I'll use a different shape, like a half circle, to keep things visually clear. Once the shapes are in place, we can build a quick FK-driven logic, for instance using the FK chain function. With this setup, the whole eye system becomes much easier to adjust without relying on every individual control. Of course, the exact approach might vary depending on your character, but the principle remains the same. As you can see, the default pose of this character has the eyelids completely closed. You can adjust the default pose or rotation of specific bones before any solvers come into play, by using the construction event. Just drag and drop the bone you want, add a set bone node, and change its rotation or position as your new starting value. For example, by tweaking the X rotation of each eyelid, I can open them slightly and create a new default pose. This makes it much easier to see what's going on with the eyes and pupils while we work. Now, onto the eyes themselves. The best way to handle them is by creating a control for each eye joint. In our case, the eyes are perfect spheres, which is ideal. Having a perfectly round shape makes everything from working to animation behave much more smoothly without odd deformations or extra skinning issues. For the control, I'll pick a circle shape, but this time I'm offsetting the entire control, not just its shape like before. Whenever you offset a control like this, make sure to lock its new position. Just right-click on the control and choose Set Offset Control from Current. Now repeat the same process for the other eye. As you will notice, the goal is to place this control in front of the head. This sets us up nicely for adding the IM constraint logic. which will drive both eyes toward a target, while still giving us the flexibility for individual adjustments. These controls will let us move each eye individually, which is already super cool. But in the end, we also want a parent control that drives both eyes at the same time, so we can keep them aligned and looking straight ahead when needed. To do that, let's create a new control in workspace. I call it EyeBoard control, and we'll position it in line with the individual eyes controls. A good trick to place it precisely is to check the offset tab of one of the eye controls and just copy those values over. Once that's set up, simply parent the individual eye controls under the new EyeBoard control. Now when you move the parents, both eyes follow together, but you still have the flexibility to adjust each eye independently on top of that, which makes the system much more versatile. Let's move on to the forwards of logic, and honestly, this part is really simple. The easiest way to get the eye movement working is with the IM Constraint node. All you need to do is specify the eye bone, then assign its parents, which will be the individual eye control. Double check the axis settings in case something looks off, and once that's corrected, you're done. Repeat the process for the other eye, and in just a few nodes, you've got a complete and efficient eye rig system. The IM Constraint node will also give you a lot of flexibility. You can filter which axis you want to constrain, or even switch the space targets. It defaults to world space, but you can set a custom one. And under Advanced Settings, you also find debug visualization options to help you see the IM axis more clearly. And if you want to go further, you can add nodes like drawline or drawline strip to create custom debug visuals, such as showing the links between the eyes control and the EyeBoard control. You can even hook this debug option up to a Boolean animation channel on the EyeBoard control, so you can toggle them on and off during animation. Now, let's move on to the final step, controlling the eye attributes that live inside the material. For this example, I'm using the MetaHuman eyes. If you take a look inside the material instance and break it down, you'll notice that cornea size and pupil dilation are the key attributes worth driving. These are perfect to animate. Look at that Puss in Boots style wide-eyed effects. In Unreal, just like morph targets, you can drive material parameters using curves inside the control rig assets. Here's how. First, go to the skeletal mesh assets and create new curves with names that exactly match the material parameters you want to drive. In this case, cornea size and pupil dilation. Make sure you set their type to material curve. After adding them, go back into your control rig asset. Inside the curve container, refresh the list by right-clicking and importing from your character. That way the new curves appears in the rig. Everything else happens in the forward solve event. Use the set curve nodes. You'll see all the curves attached to your mesh listed there. Since these are float values, we can drive them directly with float animation channels created on the EyeBoard control, for instance. Just map the channel values to the curve inputs. Now during animation, whenever you select the EyeBoard control, you'll see those parameters available. From there, you can easily animate pupil dilation or cornea size in real time, adding extra life and expression to the eyes. Everything is in place, fully manipulable just the way we want, including the material parameters of the eyes. And here's another important point to add. We want the option to lock the position of the Constraint EyeBoard. The good news is, you don't need any extra nodes in the control rig for that. You can simply use the space switching feature in animation mode. Just switch the EyeBoard control space to world, and now our character's eyes will stay locked on that target for the rest of the animation. By the way, I've already made a video that dives deeper into space switching, so if you want more details, check the link in the description. So, to quickly recap, we created a control rig with a simple FK setup for the eye master control and the eyelids. For the eyes themselves, we use the Constraint node to build the direction logic, with the option to add debug lines if needed. For the eye materials parameters, we made new curves matching the names of the export's attributes in the materials, then drove them using a set curve nodes connected to Float's animation channels. And finally, everything is ready to animate directly in Sequencer with controls that are flexible, simple, and reusable for any character. And that's it for today. I hope you enjoyed the kickoff of this series, Rig It. I'm counting on you guys to let me know in the comments what you think about that and waiting for your feedback to continue the series. And I don't know if you noticed that guys, but now you got a new feature which is the boost. You can now boost the video in addition to sharing, liking and subscribing to the channel. So I'm counting on you on that too. See you next week for a new one. Ciao.